Let us consider electrical load ratings. We have already said that the reason for going solar is so that you can power some or all of your electrical loads. So your inability to understand how electrical loads are rated or are rated will pose a big challenge when you are designing a solar system. And we are saying that it is not professional for you to install a system, a solar system, without taking your time to go for power audits. And when you go for power audits, one of the requirements is that you look at the ratings of each of the electrical loads and equally know the hours in which the electrical loads will be operated. We are designing a system that will take care of day use equipment. The approach will be different. We will talk about that later. The approach will be different from designing a system that will be operated at night. So in the same vein, if I'm designing a system in which the electrical loads maybe is like 1000 watts, then I'm designing another system in which the electrical loads is like 350 watts. The design will be different. So the electrical loads affects how you design your solar system. That is, the rating of electrical loads affects how you design your solar system. So to know how electrical loads are rated, you'll always look at the electrical load nameplates. Even when you are buying solar components, for you to understand the features, how the the solar components will be configured, and every other thing you need to look at the nameplates or the data sheet. It is the operation manual that tells you everything about the component that you are buying. There's no component you buy in the market that you won't have the data sheet, or if you don't see the data sheet, the nameplates will always be there to guide you. And we said that it is always at the back of any equipment that you buy. We are saying that the rating of an electrical appliance indicates the voltage. That is, you will always see the voltage. Not only the voltage, you will always see the current. Most times you see the the power factor of the electrical load. You most times see the efficiency of such an electrical load. Those are some of the data that you always find on your nameplate or data sheet. There are much to what I have mentioned when we will be talking about solar inverter. We will dwell more on those features. So these figures are usually displayed on a rating plate attached to the appliance, that is the nameplate. For example, you might see an electrical load that is rated 220 volts 5 amp. Then we are saying that the rating of an electrical load relates to the power it consumes. That is the power such an electrical load will consume when we plug it. A nameplate of an electrical load. We have talked about this already. The information on the nameplate of an electrical load specify the voltage at which the electrical load is meant to operate. The voltage and the current. It defines the parameters for the electrical load, such as power factor. We have said this: efficiency, current at the rated voltage, and frequency. So when you go for power audit, it is required of you to look at the nameplates. Please don't forget this. Look at the nameplate. The nameplate will give you every detail about the electrical load that you want to power with the solar system. And when you sum up all the electrical appliances that will power with the solar system, you get direction on how to go about the design process. When the electrical load is used at other voltage than the rated uh, voltage on the nameplate, will tend to affect the performance. Sometimes it end up destroying the components or electrical load, even solar components. If you don't know the nameplate, if you don't have the nameplates to understand how you go about maybe configuration and other things, you end up destroying such components. This is a typical nameplate. This is how a nameplate looks like. Rating of household electrical load. Household electrical loads are always rated, so always look at the nameplate. That is the information we are passing in. Manufacturer's literature and equipment nameplate of any electrical load or electronic device often lists the power consumption of any electrical appliance. Manufacturer's literature, that is the data sheet and nameplate, will always inform you of the rated power the equipment will consume. The nameplate shows all the information about any electrical equipment that you purchase. So don't just go to the market and say, I want to buy this. Always ensure that you look at the nameplate, especially when you want to run such an electrical load with the solar system. Whenever you look at the nameplate, we have already said this, you always look at the power consumption. You always see the power consumption of the electrical load. That immediately informs you of the power consumption of such an electrical load. If this is not available, the manufacturers will always include the voltage and the arm of the on the nameplates. So what we are saying here is, if you go to buy an electrical load and it is not rated in watts, you always see the current and the voltage. So when you multiply the current, remember P is equal to I. The power is the product of current and voltage. So when you go for any electrical load, maybe you are going for power audit, you don't see it rated in watts. The manufacturers will always give you the voltage and the current. When you multiply those two parameters, it will give you the power consumption of such an electrical load. Those are the parameters you make use of to know the power consumption of any electrical load. This invariably will tell you the size of solar system that will be suitable for particular facility. So when you combine all these electrical load ratings, you certainly know how to go about designing of the solar system that will power the electrical load. We will talk about system design in our paid training. So if you want to understand how to design each of the solar components professionally, I will advise you to do well, join our training, and you get the best when it comes to. There is no solar system components that we will not show you how to design when you join our paid training. Thank you for watching this. Okay, in summary, because we are gradually winding up power audit so that we can move to the next thing. In summary, electrical loads are rated in watts. That is the unit for power. We already know this. And you know that power, P, is always equal to current times voltage. P is equal to IV. We have explained this, where P is power, I is current, V is voltage. So we are saying if the electrical equipment is not rated in watts, don't worry yourself. Don't say how, what am I going to do? There is always a way out. You will be provided with the current and the voltage consumed by the electrical load. So if you don't see it rated in watt, don't worry yourself. Just multiply the two parameters given, and that will give you the power consumption of the electrical equipment. Then for the people that are interested in our training, you can make your payment to this company's account. If you are in Nigeria, make your payment to the company account and DM us, and you have access to our paid training and our mentorship. We are looking at typical wattage requirements of common household electrical appliances. So typical household electrical rating is what we are looking at now. So if we switch, you'll see something like this: typical wattage requirements of common household electrical appliances. These ratings are only estimates. Most times you can browse to know the rating of each of the electrical load that you are dealing with. You check it on the internet. These are some that we have been able to lay our hands on. You can always confirm this with the nameplates. We are saying that this is just estimate of some household electrical appliances. That is what we are saying. You can see some of the electrical appliances that we have listed here and their power rating. We are saying that these are only estimates. So the next thing we will consider is, we are done with typical wattage requirements of common household electrical appliances. Let's look at templates for data collection during power audits. We normally when we go for any power audit, we normally go with a template, a data sheet, or sorry, a form in which we document everything that we do. This is a typical template we use: Sockway Energy Academy, Solar Installation 101, Site Audit. This is for electrical documentation. So the first thing you are seeing here is customer's information. The customer's information. Client, that means you write the name of the client, Mr. ABC. Anyhow, that is this particular row. You write the name of the client. This is serious business and you must take it very serious. Site full address. Where is the site located? In which part of the country? The states. So you have to put in the address of the site you want to do the power audit. Most times issues might arise and you are required to provide all this data. Location, the state, the region, the country, business type. We talk about residential, commercial, industrial. Maybe it's a business center. So they just write the business type. That if it is a residential building, just write. If it is a bank, you write it's for commercial purpose. Then anyhow you put it there. Then primary contact person. Who do you meet when you go for power audit, and you equally record the person's phone. This is the column for the recording. This way you use for the recording. So primary contact person name and phone number. You have to get the person name and the person phone number in case, or if not in case, so that it will be easy for you to communicate. Maybe you forgot some things and you need to ask the person, please check this information. When you are going for commercial installation, there are times you get exhausted and you forget some things. So you really need to have somebody's contact that you can always communicate with. Consultant detail name, that is the company that went for the power audit. That is the consultant detail name, phone number, and email. So you have to write the name, company, the phone number, and maybe probably your email, then the date you went for the power audit. We have the electrical load information. We are going to analyze this so that you really get to understand what each column here stands for. What each column here stands for. We'll come back with another video. Okay, let's continue from where we stopped. We are talking about power audits, and we are saying that we have a template that we use when we go for power audits. This template is for a residential power audit, and it talks about electrical information of the facility. When we are going for a commercial or an industrial power audit, we use a different template for that. Then the first thing you are having here is the serial number. You number it serially. 1, 2, 3, 4, depending on how many electrical appliances you have on the facility. The next thing you are having here is the item. Which electrical load are you considering? We are not talking about bed, your bed or your kitchen utensils. That is not what we are talking about. We narrow it down to electrical load. We said this before. So item is it television, AC, laptop, and the rest. You list them here. Condition, location is where is it located in the facility. Which part of the facility? Is it in the dining, parlor, and the rest? Condition talks about is it in a working condition? Is it in a working condition, or it is not in a working condition? If it is in a working condition, just write good. If it is not in a working condition, write bad. That is what it means. The reason for this is you have to write this so that you know exactly whether the client will fix up that electrical load and still make use of it when you install the system. If he or she will not make use of that electrical load again, good and fine. That means you will not capture it in your design when you are designing the system. But if he or she will make use of that electrical load when you finish installing the solar system, you have to include it in your calculation, bearing in mind that he will replace it and still make use of it. Or if he will change it, maybe go and buy another electrical load, you have to ask. Maybe he was using a 3 television before, 1 or 2 breaks down, and he has been using 1. When you certainly fix the solar system, you will start enjoying the solar system, and you will have needs to go and fix up other television. So if you don't capture it while you are doing the power audit and it fixes them and start using, it will affect the performance of the solar system. So that is the reason we are saying that you have to include any plan for replacement, and you have to equally ask the clients, his future electrical load, how will his electrical load be 3 to 5 years from the time you install that system. Certainly he might be a bachelor when you went for that particular power audit. If he gets married, children will come in, the size of the electrical load that he's using on that facility will certainly increase. So you have to equally, though we have not captured that in this power audit, but it's included when you join our paid training. There are other things we can now capture here. We just selected few and try to communicate so that you understand what to do. So you have to equally ask of future electrical load how it will look like. So any need for replacement, and equally you have to ask, please, Sama, when you replace this electrical load, what size do you think of buying? Will you buy the one bigger than this, or will you buy the one smaller than this? This will give you a clue as to what to write, and maybe other question you might have needs to ask him or her. So if we are not talking about the physical size here, we are talking about the rating, the power consumption. We have already said this. The power consumption is what we are after. We are not talking about the physical size here. So that is any plan for replacement. So please always ask for this particular information to be provided uh, when you are going for power audit. Any plan for replacement, and equally know the power rating that he or she will replace the non-working electrical load when you install the system. And sometimes ask for future electrical load, how it will look like. Then the quantity, how many do you have? How many? Is it 3? Is it 4? Is it 5? Is it 6? Your quantity here. Unit watts, we already talk about rating of electrical load. What is the size? What is the power consumption? So you put it here. Total watts. Total watt. What is the total watt of maybe television here? So when you have the quantity and you have the unit watt, maybe you have 5 here, 5 as the quantity, and each of it is rated 20 watts. You have 5 here, then each of it is rated 20 watts. So what will be the total watt? That will be 5 times 20. That will be 100 watts here. That will give you, that is how to get the total watt. Unit watt, or sorry, quantity times the unit watt will give you the total watt. This is the column we are discussing now. We said item, location, condition, any plan for replacement, unit quantity, unit watts, then the total watt. We are here now. Then the next thing is appliance operating hours. How long will you use each of the electrical load? 3 hours, 2 hours, 5 hours, depending. You have to ask him or her as to how he normally make use. Maybe television. He might not be running the television 24 hours, so you need to ask. Maybe typically he runs it at night. The time of usage of the electrical load, you still have to ask. There are other information we can't capture here. That is the reason most time when people say there is a software for designing system, we say no. We know that there are software, and we have seen the interface. If it works for you, no problem, but we do our own manually, so that there are certain questions we need to ask the client in which such questions are not captured in the software. So if your software works out for you, perfect and fine, no problem. We are not against using the software. So appliance operating, there are certain things I would love to say, but time doesn't permit me to say. You hear of those information when you join our page crawlers. So appliance operating hours. How long? Is it 3 hours, 4 hours, as the case may be? Then total watt hour. If it is, like AC, fridge, you might not be running those electrical. They are heavy loads, so you will not certainly be. If you say you will be running it for 24 hours, no problem. We will advise you. We will tell you the implication of running AC for 24 hours. We'll tell you the implication of running your fridge for 24 hours, because those are electrical load that really consumes power when we talk of installation. So you have to include that total watt hour, then the total wattage multiplied by the appliance operating hours will always give you the total watt hours of each of the electrical load. So this rule, you have the total watt hour. This particular rule you equally have. So you sum all the total watt hours and you have an answer to it. Then another thing that you have to ask, or you have to know that by yourself, is what is the peak sun hours in your location, in that particular location. Don't ask the client will not understand. So you have to figure out the peak sun hours. Is it 3 hours? Is it 2 hours? Is it 5 hours? Is it 7 hours? So all this information will really help you. There are other information or data that there are other information or questions that we ask the clients, and I think that those questions were not available here. That we capture them when we are talking about asking the right question. So I will advise you do the needful. So what is the peak sun hours? So that is how the residential template looks like. When we move to commercial solar installation and industrial installation, it would be a total ball game. With what we have discussed so far, there is an assignment section in which we want to test your understanding, or if you are following us to the next level of this discussion, we want to test you so that we can use the information or the data you provide to design the different solar components: the solar inverter, the solar battery, the solar charge controller, and the solar panels. We will use the information you provide or give us to design all the solar components and probably show you how to do that. Then we design the entire system and show you how to go about the installation process. So we are saying that in your facility, you should do the following: fill the table. We have provided you with a table without leaving any space blank. When we were explaining it, you didn't see us jump any step. There is need for that. And if we were to do commercial or industrial solar installation, there are more to what we have just said. Fill in the customer's information as provided. Locate the client name, the location, business type, etc. That is what we are asking you to do. List all the electrical loads. Very important. List all the electrical loads accordingly and specify the name of the electrical load. We have to know the name. We talk about types of electrical loads. When you list, you have to include the name of the electrical load, because we need to know the type of electrical load, as we have discussed that type of electrical load affects the sizing of the solar components. Then from the information, do the following: what is the peak sun hours? What we have already discussed. In your location, because it will integrate that into our discussion. Specify the location of the items. We have said that. State the condition. We have showed you how to. We have deliberated on that. If any electrical load is bad, is there any plan for future replacement? Yes, you have to specify that. Specify the quantity of each of the electrical load. Then specify the unit watt of each of the electrical load. That is what we just finished discussing. Then specify the total watts of that particular type of load in your facility. What is the total watts? You know, when you get the unit watts, then the number of electrical load, you get the total watt. Then on average, how long in hours? If it is minutes, no problem. How long do you use each of the electrical load? If it is a client's house, ask the client the duration of usage, because we will certainly need that when we will be doing our calculation of system sizing. What is the total watt hours of each of the electrical load? We told you how to get the total watt hours of each of the electrical load. So follow same and fill the form. Then we'll tell you what next. Then we are saying here, hint, we have already discussed it. Total watt hours is always the total watts times the hours of usage. Then when you finish that, sum all the total watt hours and let's have a unique this thing. Total watt hour, that is what we are saying. Add all the total watt hours in the last column to give you your energy consumption in your facility. Well done if you will be able to do this. Then, if you are joining our master class, that is a paid class. So, when you finish that assignment, send it to the company email, training at subwaylimited.com. Training at subwaylimited.com. Then WhatsApp this number or call or WhatsApp anyone. Will inform you of what to do next. Then, if you are able to do this, congratulations. The information you have provided is what we will use to design the size of the solar system that will power your electrical loads in your facility. The information will help us. The information you have so provide is what will help us determine the size of the inverter. It is what will help us determine the battery bank. It is what will help us determine the number of solar panels. It is what will help us determine the size of the charge controller and other accessories. In fact, it is what will help us know the cost of the solar system and everything that surrounds the installation. So, distance cannot never be a barrier. We are having physical training, we have online training, but our own policy is you first of all join the online training before you think of coming for our physical training, because everything we do offline, that is offline in the physical training, that is exactly what we do online. We don't have that time to come and start talking about power audit and all the details we will be discussing in our physical training. That is the reason we are saying you join the online training first, so that everything we discuss there. And for the costs of our training, always check our website, because the cost varies. So do well to always get this information from our website, or you DM us. We will be kind to tell you the cost as per time we are running our paid and our physical and our online training. So do well to make your payments to the account detail. After that, you DM me. I believe this information will certainly be of help to you. And if you join our next level of training, you certainly understand what we do. We have taken our time to expatiate on power audits, because power audits is the very first thing you have to do when you are embarking on any solar system installation. When you miss it at the power audit stage, everything you'll be doing, you might not get it. So we have listed about 5 reasons why your solar system installation failed. We will continue listing it, but we will not be elaborate as we did to power audit, but we will take our time to talk about types of solar system, different solar system types, because that is another important thing that affects your design or the functionality of your solar system installation. Because when you don't know the type of solar system a client is in need of, you might end up giving something that will not meet the requirement of that client. So when most times you go for power audits, then the power audit is conducted poorly. You have gone for the power audit, but this power audit is not professionally carried out. So poor power audit is another reason why we experience solar system failures. We have listed a step-by-step approach on how to go about proper power audit. So If you go for the power audit, but you don't take your time to go and do the power audit professionally, your solar system installation will still fail. So poor power audit is another thing that causes solar system failure. Then another thing among the 49 reasons why your solar system installation fail is poor data gathering. There is a way you gather data when you go for power audit. You go for power audit, but your data acquisition is not professional. So it's always good you go with a template. You go with a template so that you do everything accordingly. You don't miss any step. That is the reason we go for our power audit. We go to the site with a template. We sit down and list everything we need when we go to site so that when we go, we document it professionally so that we don't miss anyone. So poor data gathering, because if the data gathering is poor, certainly the interpretation will be poor. So another thing that causes solar system failure among the 49 reasons we will list is poor data interpretation. When the data gathering is poor, data interpretation will equally be poor. Most times, the data gathering might be professional, but the person that is designing the system will interpret the data poorly. So, poor power audit, poor data gathering, poor data interpretations are other reasons that causes solar system failures. So there is a reason to go about power audit. There is a way to go about power audit professionally. There's a way to go about data gathering professionally, and there is a way to go about data interpretation professionally. So another thing that causes uh, solar system failure among the 49 reasons we are going to show you is professionals inability to educate their clients on energy management opportunities. If you go for power audit, or if you want to install a system for a client, you need to educate your client very well. Even when you are finished installing the system, you need to educate him on power management, not only energy management opportunities only. Because some client think that when they have solar system, they should not be anytime they should maybe switch off their inverter. Sometimes you have to switch off this inverter, let it rest. It is an electronic device, it's man-made. Even things that are made by God, there's always an expiring date. If you work for 24 hours a day, all week, you certainly break down. So there is always need for professionals to educate their clients on energy management opportunities and the best way to save power. If you are using prepaid meter and you buy recharge card to put on the maybe conventional power source, will you be putting on your lights even in the daytime when you are not even using it? If you are running your generator, will you be, maybe even when you are not in the house, you still run the generator? You certainly shut down the generator. This is what we are saying. Energy management. Energy management. You need to know how to manage power. If you don't know how to manage power, you end up recycling your battery, charge and discharge, and before you know it, the life expectancy of the battery will not be able to save you. So it is always okay for a professional to always educate the clients on the best way to go about managing power when they go. Welcome once again. We are still talking about 49 reasons why your solar system installation failed. And we are considering number 10. We will be a bit elaborate about number 10 because some people don't really understand this concept. In the solar industry, we have different photovoltaic system types. We have different photovoltaic system types. And you know that solar components can be configured in many ways for the purpose of delivering electrical energy to the electrical loads. So based on this, there are different approach we use to design solar system. The way we design a stand-alone system is not the same way we design maybe an on-grid solar system. So we basically have different types of solar system, and all of the different types of solar system requires different approach during the design process. If you take a closer look at this, you'll see integrated photovoltaic battery charging system. A client might come to your office if you have one, or if you're a professional, you don't have an office, and he calls you and asks you certain questions about the solar system. Which one do you have? This is my budget. If he said he has like 200,000, 200,000 naira, a good battery is around 150,000 naira, a good battery. So if a client is offering to give you, or is budgeting 200,000 naira for a solar system, you should certainly know that he doesn't need a full-blown system. He needs an integrated photovoltaic battery charging system, in which you have the solar panel, you have this, some people call it solar generator. This is the inverter that will convert the DC generated by this solar panel into AC. The inverter is inbuilt here. The battery is also inbuilt here. The charger is also inbuilt here. So some people call it solar generator. You can use the solar panel to charge it, and you can see this adapter whereby you can charge it with the conventional power. So this is the drawing. You can see you can use the solar panel to charge it. Just one panel is okay, depending on the rating anyway. So you can equally use the conventional AC power to charge this solar generator. Some people call it solar generator. So most times the LED bulb that comes with this solar integrated photovoltaic battery is always of very low wattage. You can see 9 watts LED bulb, and the number is always specific, maybe 3 or 4. It's customized, so there's nothing you can do about it. So that is this. Then some of these solar generator, some people call it, we love saying solar generator. Some of them, depending on the rating of this customized package, can carry television. But most times when we look at the costs, we don't normally give our client this one, because most times when we look at the cost of that integrated this package that will run a television is equally the same cost of running installing maybe 0.8 kVA or 1 kVA. So we like advising our clients, instead of buying this one, why not maybe ask more money, or you just go for one battery, 1 kVA or 0.8 kVA. It will save you, it will carry more load than the generator, the solar generator that runs only television, you charge your phone, then just one panel. The same cost, we can give you 3 panels
with maybe 0.8 kV or zero point 0.5, and it will run your television, run other, charge your laptop, do a lot of things, run your fan. And most times we prefer advising our clients, if you want the solar generator that will power your television, it is the same cost, very small difference, that you will invest in going for a 0.5 or a 0.8 kVA system that will power more load than this packet that will run your television. I'm saying there are other smaller packets. There are smaller packets that will only charge your phone, give you lighting point. What again? You charge you play your radio. Some of them come with radio. So if you are going for the one that will run your television, I am saying that the cost most times is close to the one you will use to install a 0.5 kVA system that will carry television, carry more load, laptop, and almost all your lighting points in your house. I'm saying this with experience. The cost of running the packet that will run television is equivalent to the cost of running a full-blown system, maybe one battery, maybe 3 solar panels, and with charge controller and inverter. Then you install it. It will give you uh, more energy, more opportunity to run more load than this particular. We are not saying this one is not okay, but if you are going for maybe lighting point, charging on television, but if you need the one that will run fan, run television, and maybe run your laptop, the cost, that is what I'm saying, the cost is almost equivalent to the one that will run, that is 1 kVA system. That is the very first type of photovoltaic system type we have talked about now, the integrated photovoltaic battery charging. Okay, let's us consider another type of solar system installation, which is the solar generated borehole. You will see in your community, governments will execute borehole projects. Most times is this setup in which you have the solar panels, then you have your GP tank, and power will be able to pump from deep down beneath the earth so that people can consume it in your community. People will come and fetch that water. So such system type is regarded as day-use systems, in which they are only operated during the daytime. Basically, the solar pump that you can see here is a DC type, in which it will work. Remember, your solar panel produces DC, and the power will be used to draw pump up this GP tank. So at night there will be no sun, and this setup will not work. So when you are having such a setup, it is referred to as a day-use system. Most times clients will come to you and ask you that he or she wants to install a system that can carry pump the borehole. Sometimes people will say they like this structure, they like this setup, but the truth is the cost of running this setup is very close to the cost of running an AC pump. And remember, during the daytime, these solar panels will generate enough power, and if you have the storage, which is the battery, you store the power that will be generated. It's not every time you pump this water. So when you store the power generated, you will be able to use it at night. You equally use the power generated to power other electrical loads in your facility. So we don't normally advise clients to go for DC or DC's pumping system. It is wisdom if you can advise your clients to go after AC pump, in which after the installation the excess power can as well be used to power other electrical appliances in the building. Then we have another type. Remember, we are still talking about 49 reasons why your solar system installation failed. And we are on number 10, the inability of professionals to understand the type of system that a client is interested uh, in installing. So, DC load center, 4x3 solar panels, solar charge controller, DC home appliances, DC systems with storage battery and battery bank. In this setup, it is a DC system with storage battery. It is not an AC. Remember, your power, your electricity can either be AC or DC. So what happened here is the solar panels we all know generate DC. This charge controller, what is the function of the charge controller? It is to regulate the charging of this battery. We bring in the solar inverter to convert DC to AC. That is the function of the panel, the charge controller, the battery, and we have not included the inverter here because it's the DC system with storage battery. So we normally bring in the inverter to convert the DC generated by the panel or the DC stored by the battery to AC to power our electrical load. So remember, your charge controller is to regulate charging, else this solar battery will be overcharged or undercharged. When we get to the main thing, we'll talk about all these components in detail. So when we are talking about DC system storage battery, this solar panel will produce DC and it will be stored here with the solar battery or inside of this solar battery, and it will be operated with DC load. There's no AC component here to convert. So we have DC fridge, we have DC fan, and we have DC AC. So all these ones you are seeing, they are DC, so they will work well in this other setup. So there are some clients that they don't have the money to buy maybe the solar inverter. They can afford the battery, maybe buy the charge controller, buy panel, but there's no money to buy. They will buy it and add to the system later. But for the time being, they might want to use this. We have been installing this for clients. Basically, in some hospital, you see them use DC fridge. That is a different setup. They use DC fridge without the solar inverter. So that is the reason we are saying that you need to really understand the type of system a client is going after. So this is a DC system with storage battery. That is number C type of system. Then we also have the batteryless configuration. The batteryless configuration, when we are talking about the batteryless configuration, that means it is a configuration in which the battery is not incorporated into the design. The battery is not incorporated into the design. You have your solar panels here. This inverter might be hybrid or it might not be hybrid. That is the reason you see we have not connected the charge controller. When I say hybrid, that means the charge controller is incorporated inside of this inverter. So when you connect your panels to the inverter, will convert without the storage battery. Remember, there's no storage battery here. The storage battery can be added later. So in a batteryless setup, the panels will generate DC and the inverter will convert it to AC to power the electrical load without the battery being incorporated into the system. You can see batteryless configuration, 4 by 3 solar panels, 4, 1, 2, 3, 4 by 3, 4 by 3 configuration when it has to do with panel. This is the inverter, hybrid inverter. This is the charge controller. This is what will regulate the charging of the battery. Battery bank, there's nothing here. Then generator, maybe later the person can come and integrate the generator. But for the time being, it doesn't have money to buy. It doesn't. So sometimes we install this for plants. They don't have, because batteries are very costly. They don't have money to buy the battery. So we can just. But remember, there are advantages and disadvantages of using each of these setup. Those things are included inside of the textbook. There are advantages of using this batteryless setup. There are disadvantages. All are incorporated inside of the textbook. So that is another setup that a client must be interested. Okay, let's dive into another type of solar system setup. We are saying that the type of solar system setup affects the functionality or the durability of the solar system, and the inability of a professional to understand the type of the system, the solar system installation a client is in need of can cause solar system failure. A typical example is we are having a standalone solar solution here. When we are talking about a standalone solar solution, it means that all the power need, all the electrical loads here will be run with the solar system installation here. A typical example is if you go to areas that they don't have the conventional power source or there's no generator. That means if they install the solar system, it is virtually the solar system is going to run all the electrical loads alone. There's no generator, there's no other alternative power source. So when you are designing systems of this caliber, it tends to cost more than designing an hybrid system in which you have other power sources. So, and if you design an hybrid system that incorporate other power sources and later those power sources tend to have issues and all the electrical loads are powered with the solar system alone, which was not designed to be standalone, the system will certainly get an issue. So what we are saying that this is a standalone system in which it is only the solar panels here that will deliver power that will be using to charge this solar battery. And when you are designing system of this caliber, the cost is always on the high side because you need enough number of solar panels to effectively charge this solar battery, and as well enough storage to power this electrical load, especially at night. We have this other setup in which we don't have the solar panel. You go to some homes, they don't use the solar panel. They just charge the battery through generator and utility. All these things to reduce the cost of solar system installation. Because if you don't buy solar panels, no roof racking, you only buy battery and inverter. And maybe when the grid goes off, or maybe you off your generator, you power some of the electrical loads with this setup. So this is a standalone solar system without solar panels. Then we have another setup. This is the hybrid solution I was talking about. So when we are saying hybrid, that means two power source. Hybrid, we say hybrid inverter. That means there is a charge controller incorporated inside of this inverter. So a hybrid setup incorporates other alternative power sources for the purpose of charging the solar battery. You can see we have the solar panel here. It will charge this battery. we have the utility here. Will equally charge this battery, and sometimes they will on the generator, and the generator will equally charge the solar battery. So designing a system like this will not be too costly, because you won't really need much solar panels, because and you know for sure that there are other power sources that will assist in charging the solar battery. But the issue is, if you design this system as an hybrid solution, later the PHCN, that is the utility, gets issues, the generator gets issues, and remember, you do not properly size this system as a standalone. You design it as a hybrid setup. Then, if peradventure these two power sources get issues, and it is only the panel that gives the needed power for the charging of this battery. If the client don't communicate with the professional, or if the professional don't call the client to ask about the performance of the system, this system will get issues within the shortest possible time, because it was not designed as a standalone system. So that is the reason, and that is how the type of system affects the design, and it also contributes to failure of solar system installation. It happens most times. So that is the reason we are saying monitoring as a professional. You need to always communicate with your client to know how the system is faring. Because most times, if you design a system as a hybrid system, later these power sources get issues. You have a solution to the problem, and you have to advise the client accordingly. Then we move to another source, or another type of solar system installation. You can see here, this is the Fronius inverter, the string inverter, grid tied system without uh, battery storage. Well, I will not dwell much on this. This is a grid tie system. We make use of this inverter a lot. It's a string inverter. It's not common. Most people don't um, really get to use it. It converts DC directly to AC, so there's no battery setup here. So when you are going large scale, you want to install large scale system, it's pertinent to use something like this. So this is a grid tie. That is, you send this power to the grid. You can sell this power to the grid. Then we have another type, which is the same grid type, but this one is with battery. The other one was with batteryless, but this is still a string inverter, but there is a storage battery. So those are some of the types of solar system installation that we have. Remember, we talk about solar system, solar inverter features. The features that this inverter have is not the same features that other conventional residential inverters do possess. So this is a string inverter. This is a grid tied system with battery storage. So those are some of the system types that we have. And when you are designing a system for a client, it's very, very crucial for you to ask the client, please, man, you try and explain to the customer the type of system you want to give to the client, whether it's a standalone system, because when it is a standalone system, the cost will be more than installing an hybrid system for a client. And you have to keep on monitoring the system. Always ask your client, if you are installing an hybrid system for a client, do well to always, every 1 month, at the end of every month, that's your customer service. You call and ask how the system. Sometimes go and check the battery, go and check, let the panel be watched, and check the terminals. Before you know it, the system will deliver effectively, and the lifespan. Okay, let's consider another point in our list. We are still talking about 49 reasons why solar system installation fail, and we are in number 11, solar component abuse. What do I mean by solar component abuse? Most times you see you install a system for a client. When you install the system, he was telling you that he will be using it for lightings alone. You design the system to take care of lighting, maybe laptop and fan. Before you know it, the client will start, because he has seen power and he loves it, he enjoys it. He will start plugging other electrical appliances, fridge, and other things. You have abused that power because it was not designed to take care of all those loads. Another scenario is you run the solar system and you see the inverter is making noise. It's telling you that the battery is low. The battery is low. Sometimes the system will shut itself down. You manipulate things, try on it again, and still force it and use it. You drain the battery totally. You have abused the system. You have abused that system. It was not designed to carry those loads that we have added to the system, or you are forcing it to carry it. You have abused it. The system, the battery is low. You are hearing that the inverter is making some beep sound that indicates to you that, please, this battery is low. I need it. The battery needs to be charged. You don't want to charge the battery, but you still want to use the system. You have abused the solar components, and this will lead to solar system failure. Another thing that contributes to solar system failure is wrong cable sizing. Cable sizing has been a very big challenge in the solar industry. Voltage drop and every other thing. So we will talk about cable sizing in detail, but know that your cable, the way you size your cable, can affect the performance of your solar system. It might it might not allow your panel to deliver the needed power it's supposed to deliver. It might not allow your battery to be properly charged. So there are many reasons why you need to understand how to appropriately or professionally size the solar cable. We'll talk about this when we get to solar cable size. Excessive running of solar cable. Voltage drop always sets in when you run solar cable. The length of running of the solar cable is too long, so there is always voltage drop, and this would always cause solar system failure. Example is especially when you are connecting from the solar battery to the solar inverter, you need to reduce the length of cable you use. It causes so much issues in the solar industry. So always bring your solar battery close to your solar inverter. We'll expatiate on this. Then number 15 is wrong cable termination. You can see how we terminate the cable, the battery terminals here. You can see how we terminate the battery terminals here. Even if it were to be a residential solar installation, we still terminate the cable professionally. So it is very, very crucial to always terminate your cable professionally. Wrong termination can cause fire outbreak. If you don't terminate your cable properly, it can cause causes fire outbreak. So you need to understand how to terminate cable professionally. You can see just cutting cable and maybe solar panel. You just cut the cable and use tape to sellotape. It is not professional. You use MC4 to connect this. This is still wrong cable termination. So we will talk about cable connection, or maybe the use of MC4 during cable termination and how to professionally use it. So we are just trying to highlight some of the reasons why you are having solar system failure. there are many disadvantages to this action. So it is not professional for you to cut solar cable and peel it and join it. Always make sure that you use your MC4 when you are terminating your cable. As you can see what we did here, this is not MC4 anyway, but this is perfect. So please ensure when you are connecting your cable, when you are terminating your battery, ensure that you do them professionally. At the end of the day, the system. Okay, let's consider another point on our list, which is not using solar rails during solar panels installation. While solar roof racking is a different course, we have treated roof racking separately. If you want to learn how to professionally rack your roof, we have a course for that. And when you install your solar panels directly on the roof, the solar panels will not be able to use power as it was designed, because there is a particular temperature range in which the solar panel is supposed to produce power at its best, the way the manufacturers program it to generate power. So if you bring it without putting all these rails and you put it on the roof directly, we are increasing the ambient temperature surrounding the solar panel, and the efficiency and the production, the output that the solar panel will produce will be affected very well. So we advise professionals to always rack their roof, do their roof racking. As you can see, if you are interested in roof racking, that is another thing entirely. As you can see, this is how we rack our roof. Irrespective of the number of solar panels we have to rack the roof. So if a client will have money to buy like 10 solar panels, why won't he or she have money to pay for roof racking? You just buy these accessories and you get the roof racked. I don't think it is your fault. It is the professional's fault because you don't insist that the client should rack the roof. Maybe you think it's not necessary. No, please read about roof solar panels, the temperature range in which the solar panel can produce the specific power that is written on the nameplate. There is a temperature in which such can happen. So it's not all temperature you have that. Then please, we are saying that you have to rack your roof professional, and your inability to rack the solar roof causes solar system failure, because when you design the system, you design it to generate a particular power for the charging purpose, for the charging of the solar battery. But if you just carry the solar panels and place it like this or directly on the roof, this panel will not produce power at its maximum. So please ensure that you always rack your roof. Another reason, number 16 reason why we have solar system failure is not understanding the load to be powered with the solar system installation. We talk about types of load. So as a professional, you need to understand the type of load that will be powered with. When we talk about the power audit, we expatiated on types of load and how they affect solar system design and installation. So always try your possible best to inquire about, ask the client the type of load when he mentioned it, you know how to categorize it. So always know the type of load that will be powered with the solar system. Then another thing is abrupt increase of load powered with the solar system installation after project execution. Most time when you install, after installing, plenty loads will come in. Those loads were not included during the design and installation process, but before you know it, they start bringing load from left, right, and center. Load left, right, and center. That system will shut down because the system was not designed to take care of all those loads. Then poor solar system installation. Poor solar system installation. We are not saying that this system is poorly installed, but we are just using it as an illustration that you should not cut cable and join. There are other scenarios in which when we take a look at the installation, we wonder why somebody will invest this kind of money, but the project is not executed properly. So poor solar system installation is one or is another reason why we have failed solar system installation. Okay, let's consider number 20 on our list, which is quackery. Quackery, we are not saying that somebody doesn't know what he's doing, but it's very important to get the right training, get the right mentorship, get the right experience. Most times, experience is the best teacher. That is the reason most times I will tell you that our installation can't fail because we have gotten enough experience in the industry. So let's not dwell much on quackery. If you know that you still need help, please seek for help. Wrong component matching. Component matching is, how do I connect? I have a 12-volt inverter. What is the size of solar panel I should use? What is the size of charge controller I should use? What about the battery? Okay, I have 24-volt inverter. What size? And I have like 2 solar battery. How many solar panels should I use and their ratings? So if you don't properly understand this and you start connecting the components will malfunction. That is wrong component matching. Then the next thing on our list is not knowing how to write professional quotation for any solar installation project. Some people will get a contract at the end of the day, they run and leave that contract. Why? Maybe sometimes the cost. Most times when we look at some people quotation, we wonder how are they going to manipulate their way, or are they buying fake products? In fact, how are they going to manipulate their way to install this? Because we know to go for a good material in the market, we know how much it costs. So when you are writing quotation, you need to professionally know how to select material. Don't be afraid to tell the customer a high price. They say better thing than money killer. So don't write quotation so that the client will give you the job. No, when the system fail, the client will still blame you. Instead, do one installation, and that one installation will spread your name, will let your name go viral because of just one installation than doing 3 installations. At the end of the day, all the installation will fail. What do you think? The client will not understand that the money you collected cannot afford a quality product. So if you don't know how to write quotation, there is going to be problem. Sometimes some people will install system, they end up going to the bank to withdraw their money withdraw their money to come and complete the project. It is not fair. It is not fair. So the next thing we have on our list here is not putting protective mechanism during solar system installation. Sometimes because of wrong quotation you wrote for a client, you don't have money to buy protective mechanism to put on the installation. You follow our installation, the one we are doing, you see the systems are properly protected. The systems are properly protected against thunder, strike, and everything, panel, all those abnormal current voltage, and we have to take time to protect the system. So not putting protective mechanism during solar system installation is another challenge we have in the solar industry, and this tends to affect the performance or the durability of the solar system installation. Another reason why solar system installation fail, the 23 reason why we have solar system installation, very important, is not earthing the solar building and the solar pump. Not earthing the solar building and the solar pump. You have to earth. Check. We talked about earthing when we were deliberating power audit, that you have to test for earthing of the building. Earthing is a different concept. It's a separate course in our coursework. So if you want to understand earthing, you have to DM us. We'll take you by your hand and teach you how to professionally earth components and the building, how to test for earthing and everything surrounding earthing. So not earthing the solar building and the solar component is another reason why we have solar system. Okay, still on earthing. It is not the building alone, the inverters alone you have to earth. You have to earth the solar panels as well. You can see what we are doing here. We are running earthing here. You can see this is the earth cable. This is the earth cable. So we earth all the components here. And another reason that we are having solar system failures, don't forget we are still talking about 49 reasons why your solar system installation failed, and we are in number 24, not using the correct solar tools during solar system installation. Hydraulic lock is here for cable termination. Then you can see other solar accessories here. So don't always lock your cable manually, please. It's very dangerous. So always ensure you look for the right tools. You look for the right tools. When we will be talking about solar accessories, we will talk about how to use each of the tool that you see here, and a video will always accompany each step of how you use this tool. So please, we are saying that for your solar system installation to stand the test of time, always look for the correct tools, always look for the correct solar tools and make use of them. The number 25 on our list of 49 reasons why we have solar system installation failure is poor routine maintenance. Poor routine maintenance to a point in which the solar panel will tell you, please clean me. This panel, as you see, it will not generate power enough output to charge the solar battery. We are saying dust covering the surface of the solar panel is dangerous. So that means the client or the professional is not doing his work of checking, always going to site, or advising the client to always climb the roof if there is any access point that the client can do this, climb the roof, or let the client pay a professional to always come along or come around to watch this panel. So we are saying poor routine maintenance. This thing you are seeing here will really affect, will drastically affect the production of this solar panel. For the people that are interested in our physical training and our online training, we advise you to first of all join the online training, because most of the discussion, the nitty-gritty, the secrets, and everything that has to do with what we do in the physical training, we discuss them when we are on the online session. We have enough time. We have the time to sit down and come up with things that we do on site. We package it. So please do well communicate with us. This is the company account. Make your payments and DM us so that we can take you by hand, show you what we do, how we do it, and how you too can do it. Equally, how you can make money and profit from this knowledge. It's not all about getting the knowledge, getting the certificate. No, that is not the issue. After getting the certificate, after getting the knowledge, what next? What are you going to use the knowledge for? So a careful understanding and careful um, analysis of this industry will reveal to you that there is lots of potential opportunities in the solar industry if you really understand what you are doing, if you really know exactly what you are doing. There are lots of opportunity in the solar industry that you tap from. I don't want to mention them here. There are opportunities that this industry can give. It will give you an edge over other people. Even if you don't want to maybe like run your own business in the solar field, your ability to be able to generate power yourself, it will give you, it save you so much stress. There will be so money that you'll be able to save because you know all these small things. We are out to educate people because we know how much it costs to generate power. If you are running your generator, if you are running your diesel, or maybe you are paying the power bill. Sometimes the power you are paying for is not even regular. So that is the reason we are advising people to switch to solar energy as the best and the one and only alternative power source. Let's set the ball rolling. We are still talking about 49 reasons why your solar system installation failed, and we are on 26 points. Poor solar system inspection. Solar system inspection is different from solar system maintenance. You have to inspect before you maintain. If you don't inspect what is happening to your system, you will know that it needs maintenance. So you first of all have to always call your client to check some things, ask him certain questions, how the system is performing, and the response he or she will give you a clue on action you should take.
So when you finish installing a system for a client, please don't say it's finished. It's not finished. You have to always go to that site or send somebody to go and look at the condition, the workability, what is happening to those components. Like these panels you are having here, it certainly needs to be cleaned. So the number 27 is not protecting solar cables with Dutch pipe. If you watch all of our solar system installation, we'll notice that we take our time, whether it is a commercial solar system installation or it is a residential solar system installation. We take our time to protect the solar cables. Solar cable is a different topic when it comes to our training, both online and offline. So if you can have a closer look at this place you are having here, you can see all these cables here that are running on top of this roof. Is well protected with the Dutch pipe. Even when we are doing our residential solar installation, you don't see any cable. You can see how we protect this cable here. You can see we don't fly cables anyhow. Your finishing should be top notch. So you can see what we are doing here. Then you can see this other one. Even though it is in the powerhouse, we ensure that we protect the solar cable well. You are only seeing the Dutch pipe. Before something will affect the cable, it will take some time. So that is the reason we have to always protect the solar cable. It's very important. It's very important without exposing it to the adverse effects of rain, sun, abrasion, and every other thing. So if you protect your solar cable, and another thing is it will add to the duty of what you are doing. The next point, number 28, is not paying attention to small details. Well, there are so many small details we discuss in our page training. There are so many small details we cannot exhaust here. We talk about that is the secret. That is the reason your solar system installation is failing. The secret, the nitty-gritty surrounding any industry is enshrined in the small detail that you say is not important. So not paying attention to small details, like you say, okay, it's not important. It's not important. You can leave your cable without protecting it. That is a small detail, but to us it matters a lot. Then another thing is poor solar system configuration. What do we mean by configuration? Configuration is um, allowing one component to work well with another component. You are having this size of solar inverter. What size of battery will you configure it to work properly? You are having this size of charge controller. You are having this size of solar panel. How do you configure them to work appropriately? This we handle in if you follow our course content, you see that solar system configuration is a course of its own. So not properly configuring your solar system will as well cause your solar system to fail. Then not adhering to the agreed operating hours of each of the electrical loads as stated during solar system installation. The duration of usage, that is the operating hours, time that you run each of the electrical load, was properly designed. The system was properly designed based on the duration of usage that you gave to the professional, that is the client gave to the professional. So when maybe peradventure you start deviating from the agreed operating hours, you drain the battery. Not that you should not be using those components, but Power management. Power management is very important, especially at night. Don't run solar system as if everything you have, it is your property, you can do it anyhow, especially when, at least if you run it at night from 6 p.m. to 9-10 p.m., you should try and shut down some loads so that you preserve the battery. When you keep on recycling the batteries, it will certainly cause solar system failure. So not understanding the sun path, not understanding the sun path before installing the solar panels. You can see how this sun is moving, So when you are using this setup, as the sun is moving, solar tracker, this tracker will rotate the solar panel to follow the direction of the sun. This is complete diagram. Morning position, the tracker will turn to face the direction of the sun. Noon position, you see the tracker will turn the solar panel to receive optimum energy from the sun. Evening position, the tracker will as well rotate the solar panel to adequately receive the solar energy from the sun. So we are saying not understanding the sun paths before installing the solar panels. Most times getting this technology or this solar tracker adds to the cost. But as a professional, you should at least try your best to understand how the sun movement, and you determine the best position for the installation of the solar panels. Okay, let's consider another reason why we have solar system failure. We are number 32, not taking in shading history into consideration before installing the solar panels. You can see maybe when this solar system was installed, these trees that you are having here, they were very tiny, like this, maybe like this. So as time progresses, these solar panels that are here, they will be on top of this roof for the next 30 years. This solar panel will still be producing power, will still be generating power for the electrical load. So 5 years time, these trees will grow as you are seeing, and they will start shading this solar panel. So in that case, continuous monitoring solve this. You can cut down these trees, or you remove it. You can see what we are having here. This is, in fact, it's better you cut the whole of these trees down. Maybe from all indication, these solar panels were not mounted under this condition, but with time, the trees here will overgrow and start shading this solar panel. So in this case, you have to cut down these trees, or you relocate these solar panels from this particular position. There are times another building can shade the solar panel. So all those things you have to take into consideration. Then the next thing is not using MC4 to connect the solar panels. We talk about unprofessional termination of solar cable. So always ensure that you use your MC4 while doing your termination. You can see what this engineer is doing. We have single way, 2-way, 3-way, 4-way, and the rest. So the type of MC4 you are using depends on your connection. You can see how we send our outputs here. So we make sure that all our cables are well terminated and they are well protected. So Another reason why your solar system installation failed is unprofessional upgrading of solar components, solar panels, battery, inverter. Let me take the battery for example. By virtue of how you use your battery, if you have used your battery for like 1 year, I'm saying by virtue, depending on how you use your battery, we will not advise you to buy a new battery and add to an old battery. It will not perform the way it's supposed to perform. We talk about this when we consider solar battery. We don't have much time to deliberate on this. So there are times you are using 350 watt solar panel. Maybe later you want to upgrade the solar panels. You go and buy like 200 watts. The panels rating are not the same, so it will tend to affect the production of the solar panel. So when you are upgrading your solar component, you have to be professional about it. At least if you want to upgrade your solar battery, let it be that your solar battery the old solar battery will not affect the new solar battery you are bringing in. So that is when it has to do with upgrading. Not that you cannot upgrade components, but you have to be very professional about it. Not considering the time of the day that the solar system should be put to use. Basically, we know during the daytime we have enough sun to help charge the solar battery and also deliver power to the electrical loads. So if you want to prolong your battery life, please always ensure that you perform some of the tasks. Always ensure that you run most of your electrical loads during the daytime, because at night, except you have an alternative power source that will help charge, maybe if your conventional power, that is NEPA, is integrated into the system, maybe at night you have power to still charge the battery, you can use it. But if you don't have any other power source to charge the battery, always regulate your charging so that your battery life, because our main focus most times is battery, because when your battery start degrading, maybe it cannot last you for 1 hour again, it will be too annoying. At night you don't, maybe even when you on your some lighting point, the system will start beeping, start making noise, so you won't enjoy it. So always try to protect your battery life when you mount your solar panels up there. If thunder strike doesn't affect it, if you keep on cleaning it with your just water, it still be producing. But when it comes to the solar battery, by the time the cells are gone, they are gone. Some people say they work on battery. Well, if it works, no problem. But the issue is you have to always protect your solar battery. Put all the protective measures, and also be able to personally know how to regulate the battery discharging and charging. Then another thing we are having here is not understanding the solar component features. Solar component features is one of the course contents we have to dwell on when you join our next level of training, because we have different types of inverters. Like I showed a string inverter, some features. If there is anything you should, as a professional, be interested in knowing, is the features of the components that you are buying. How does it work? How does it perform? This inverter I'm buying, what are the features? Will I be able to have the best output, or will it give me what I'm looking for? So you have to really understand the features of the components you are buying, because maybe you are buying a particular component thinking that it will perform a particular function, but when you bring it, you finish installing it, not only for you to notice that the system cannot perform as you think. So when it happens like that, there is going to certainly be an issue. So please always take note of
features of each of the solar components that you get. We are still making some progress. Don't forget, we are discussing 49 reasons why your solar system installation failed. It is like a compendium of decades of experience we have gotten in the solar industry, and we are listing it for you to understand, then take the necessary precaution, get the right mentorship, get the right training. Excessive battery cycling, excessive battery cycle. There is always a life cycle a particular battery is designed to last. Then some battery can be 600 cycles, 1000 cycles. I believe I've talked about cycle before. When you charge a battery and it's fully charged and you discharge it, depending on the DOD, you have removed a cycle. So if maybe a battery that has 60 cycles, you can end up removing the whole, 600 cycles, you might end up removing the whole 600 cycles within 3 months because of charging and discharging. That is excessive cycling. Not using battery monitor during solar system installation. Most times, some people don't incorporate the battery monitor to their clients. This is a different brand of solar monitor. You can see battery state of charge. Battery state of charge is different from battery depth of discharge. We are not here to talk about that, but we are just telling you that it is professional for you to always incorporate the battery monitor so that your clients can always understand the condition, how the battery is faring. As you can see from this diagram you are seeing here, battery has not received a full charge for 2 weeks. Very dangerous, very dangerous. I say dangerous. When I say dangerous, I say it's dangerous. So, but for that means for the past 2 weeks, your battery has not been fully charged. That means this is the indicator. Indicate when your battery was fully charged. This is the indicator. So this, if it is red, you see red sign here. That means your battery has not received a full charge for the past 2 weeks. It has not been fully charged. So what do you expect? What do you expect to happen? What do you think will happen to that battery? It will surely fail. So if this like this is showing the yellow here, as you can see, indicate when your battery was fully charged. This one is showing battery has not received a full charge for 1 week. That means for the past 1 week, the battery has not been fully charged. Then if it shows this other icon here, you see it, the battery has received full charge recently. That means if it's showing this color here, that means your battery has been charged fully just of recently. So it's always good you allow it to here. That is when you safeguard, prolong the battery life you are using. Then another point is point 39. It's not including current limiting device in your installation. Most times, when we install some of our installation, depending on the conditions surrounding the installation, we put current limiting device to trip off when you overload the system to protect our installation, because if the system fails, to blame us. So we have to always protect our own name so that you don't spoil the system, come and blame. So we normally put the current limiting device, not educating system owners on best way to manage power. I've already expatiated on this, so it is a very big problem. Even when they are not even using the system, when nobody is in the house, the system is still running. So it's not proper. I've elaborated on that. So not educating system owners on the best way to manage power. Power management is very important even when you are not using solar. It's very important to know how to manage power. End users taking the lead in solar system materials procurement and decision making. We don't stop clients from buying materials. We install for you, but cannot give you any warranty because we were not part of the design process. We were not part of the procurement process. So you are just calling us to come and install. We will install for you. If there is any advice we can give you, since you have already procured the materials, there's nothing we can do. So we just advise you. We try our best. Not that you should not go and buy, but when if anything happens, it's not on our head, not on our head. But if we procure the materials for you, buy the components for you, design the system, that is when, if anything happens, you can hold us responsible. Not that we won't install it the way we ought to install professionally, but material procurement is a very dicey situation when it comes to the solar industry because we have experienced a lot. Let not go far. And another thing is professional and end users inability to upgrade their knowledge and skill sets by going for further training on the latest innovations in the industry. One of the reasons we run this training is to educate end users and end users, upcoming professionals, and professionals that there are trends, there are professional way to go about installing system. We are not losing anything telling you what we know. We don't lose anything, frankly speaking. Instead of that, we are gaining. We are gaining. It's always good to be a blessing to somebody. So if we expose the secrets of what we do to you and to go and install, we won't be able to go around the whole world installing the solar system. It will not be possible. So we have to always share knowledge. Share knowledge. The reason we will not do it free is because people don't value free things. So we have to charge you and for our time, data, and everything. So you have to pay for it. So when we say register for our training, it is so that you can upgrade yourself, you can rub minds with like minds. So that is the reason. So professionals and end users inability to upgrade their knowledge and skill sets. If you are an end user and you know the nitty-gritty surrounding the solar industry, you won't spend money much going solar. You won't necessarily spend money much. At least you at least 30% of the cost of installation will enter your pocket. So you are not losing anything if you pay for our training, pay for knowledge. If you pay for knowledge, you are not losing anything. So you have to always upgrade your knowledge. And Subway Energy Academy is the best place for it. Okay, another reason why we have solar system failure is poor planning during the planning stage. Like any building, you have to sit down and plan well, starting from the power audits, system design, procurement, installation, configuration, solar system matching, and the rest. Maintenance. So you have to properly plan any installation that you are embarking upon. The next thing is poor project execution. How do you execute the projects? How do you execute the projects? You have to do it professionally. Downsizing the solar components. What do I mean by downsizing? You are having 5,000 watts loads, 5,000 watts loads, and you are using 3 kVA inverter. System will surely shut down. You are having 3,000 watts loads. You are running a 1 kVA system. You will overload the system. So that is downsizing. Then using a 24 solar system instead of a 48 solar system. Maybe when we say using, there are some systems now that is 24 volts but is 5 kVA. Not that you should not use it, but you have to educate the client, there is always a disadvantage to using, maybe instead of using a 48-volt system, you are using a 24-volt system. There is a very big implication. Instead of using 4 solar battery, you are using 2 solar battery, but you are powering a load that is meant for a 5 kVA system with a 5 kVA system that is 24 volts. Not that you should not use it, but there is always a professional way to go about designing such system, and you have to take your time to educate your clients on how to use those systems. It is because of the cost implication that forces people to go for. Not that they are not good, so it is because of the cost implication people are using it. Not that we don't use it, but we use it with serious education on the part of the client. You have to educate the client very well, else before you know it, the whole thing will be something else. I'm saying instead of using 4 battery to run a load, you are using 2 battery 24-volt system that you are supposed to use a 48-volt system. There is always a disadvantage to it. Then oversizing the solar component. When you oversize, what do I mean by oversizing? Oversizing is maybe you are having a very big load, then you don't have enough solar panel to charge the solar battery. You are using numerous solar battery, but you don't have enough solar panels to charge it. Maybe you are designing it for future purpose, but you don't have enough solar panels to charge it. Always look for the best size of system that will take care of your load, and always understand how to size your solar component well so that you don't downsize the system and you don't oversize the system. There's always a disadvantage to downsizing the solar system, and there is always a disadvantage to oversizing. We are gradually winding up this discussion. 49 reasons why your solar system installation failed. Keeping the solar component in an unfavorable environmental condition. When we install the solar battery, we love putting temperature sensor. There is a particular temperature your solar battery will perform optimally. There is a particular temperature your solar panel will perform optimally. So temperature affects the performance of the solar component. So you have to always know the environment, the condition of the environment in which you position the solar components, not understanding the sequence to follow during any solar system installation. There is always a sequence to follow, a step-by-step guide. When you are on the roof, when you are doing roof racking, there is a sequence. We have a step-by-step 45 steps to follow when you are doing roof racking. 35 steps to follow when you are doing roof racking. A step-by-step process. It's also a compendium of decades of experience in the industry. So we try and summarize all these things because it is online, so that you can always make reference to our training. So there's a sequence to follow when you are inside of the powerhouse. There is a sequence to follow when you are doing system design. Aging as a result of the number of years you use your solar components, they will tend not to function optimally. They might result in the failure of the solar system. So aging is another issue when it has to do with solar system failures. If you are interested in joining a detailed training, both physical training, if you are in Nigeria, we run physical training, but ensure you first of all join our online training, because if you don't join our online training, that is one of the criteria so that we can expose you to the secret we use. Because when you come for the physical training, there will be no time. We will go to site, do the work you see. We will go to site, do the work you see. So when it comes to everything that we do on site, we ensure that we teach them online, so that when you come for the physical training, it's just to assemble the components. You ask your question. We do more of practical. But don't forget that proper preparation prevents poor performance. The reason for attending the online training is to prepare you for the tasks ahead. There are business aspects you need to learn about the solar industry. All of this we can handle the physical training, how to design system, and every other thing that has to do with something. In fact, every of our course content you see us use, we dwell on them extensively in the online training. So when you come for the physical training, we are sure that you are already grounded, so we will be able to communicate. But if you don't join the online training, you say you just want to come for the physical training, you get frustrated because nobody will wait for you. There's no time. 1 week is not enough to cover all the course content. But in our step-by-step sequence, when it comes to the online training, we are able to take our time to teach you everything inside of the course content. Thank you once again for purchasing this video. We still remain Subway Energy Academy, training section of Subway Energy Limited. It's a pleasure